Inspire Form is a comprehensive sheet metal forming simulation environment. Its tryout tab acts as a virtual tryout press for manufacturing engineers, die design engineers, and process planners to validate the die designs for any potential defects and mitigate them before manufacturing the physical die. Let's start with bringing in the blank and tooling geometry into Inspire Form. The blank definition involves selecting a part that describes its starting shape followed by defining its initial thickness. Material for the blank can be selected from our extensive material library that is populated with SAE, European and Japanese standards, or new material can be created and assigned. The rolling direction of the coil relative to blank can be defined using the manipulator. The sequence of operation to deform the flat blank to finished part can be added from the palette that is populated with commonly used operations. The tools for the operations are automatically built and configured from the imported geometry in a single click. The attributes for each tool, like holding force for binder, can edited quickly with a click. The tools are automatically positioned in open position and moves to closed position during the analysis to deform the sheet. The closed and open position of the tools can be reviewed and edited as needed. The standard operations can also be customized by adding tools from the tool palette to meet the specific process needs. Here guide pins are added to locate the blank. This completes model setup for an operation. Successive trim and flange operations can be similarly added from the palette. Tools for the trim and flange operation can be quickly configured using the geometry with minimal effort. The blank transfer between operations to locate them for the next operation can also be defined using the manipulator. Run analysis starts the analysis from the first operation and follows through the operation in sequence as defined. Run status shows the analysis progress. Results for all operations are loaded in the same application for visualization. For every operation, the deformation of the sheet can be reviewed with animation. Typical results like percentage thinning, formability based on forming limit diagram, plastic strain are available to visualize. Force needed by tools to deform the sheet can also plotted with a click. Callouts can be used to query and get details at the hotspot locations. Material flow at discrete locations on the blank during deformation can be traced to see its path. Measurements can be added on these traces to compare with physical tryout measurements. Spotting of the blank by tool edges can be studied with tracers to look for potential tool markings and skid lines that could cause surface defects in the part. Results of all operation can also displayed and animated in the sequence as defined to get a complete overview of the material deformation from flat blank to finished part. The simulated part can be compared with design part for any deviations. Here the part boundary is longer than the designed part. To meet the design specifications at the part edges, trim lines in trim operations needs to be engineered. Instead of trial and error, the tracer in Inspire Form can be used to predict the trim line from the desired part boundary based on the deformation. This predicted trim line can be validated through iterative analysis to virtually stamp the part that meets design specification.